Hello friends! Imagine you need to print a greeting 10 times in your program. You could write the same line 10 times, but look at that. It is repetitive, it is tedious, and if you need to change the message, you have to fix every single line. Now imagine doing that for 100 items. Or 1,000. Clearly there has to be a better way. And there is. It is called a loop. Loops let you tell the computer to run this block of code a set number of times, without writing it over and over. In this video, we are going to focus on one of the most useful loops in programming, the for loop. So let's dig in. Alright, so what exactly is a for loop? A for loop is a control structure that repeats a block of code a specific number of times. Here is what one looks like. The keyword for is followed by parentheses containing 3 parts, separated by semicolons, and then a block of code in curly braces. The first part is the initializer. We set up a counter variable. The second part is the condition. The loop keeps running as long as this is true. The third part is the update. After each pass, we change the counter. These 3 parts work together to control exactly how many times your code repeats. We replace those 10 identical lines with just 3 lines of clean, readable code. Next, let's look at each of those 3 parts up close. Now let me show you what each part actually does. The initializer, int I equals 0 feet, runs exactly once, right before the loop begins. It creates a variable called I and sets it to 0. Think of I as the loop's counter. The condition, I less than 10 feet, is checked at the start of every single pass. If it is true, the loop body runs. If it is false, the loop stops immediately, and the program moves on. The update I increment runs automatically at the end of each pass, after the body executes. It adds 1 to I, advancing the counter forward. These 3 parts work in a fixed order every time. Initialize once, then check, run, update, check, run, update, repeating until the condition fails. Let's trace that exact sequence with a concrete example. Here is the interesting part. Let's trace through a real example together. This loop starts I at 1 and runs while I is less than or equal to 5, incrementing I each pass. Pass 1. I equals 1. The condition is true. We print 1. Then I becomes 2. Pass 2. I equals 2. Condition is still true. We print 2. Then I becomes 3. This continues through pass 5. We print 5. Then I becomes 6. Now the condition checks. Is 6 less than or equal to 5? No. False. The loop stops. The output is exactly 1, 2, 3, 4, 5. Notice the loop ran 5 times, which is exactly what we expected. Tracing through a loop like this, step by step, is one of the best habits you can build as a programmer. Now let's apply this to real data. Let me show you a practical example. Say we have an array of 3 fruits, apple, banana, and cherry. Arrays in C++ are 0 indexed, so the items sit at position 0, 1, and 2. Our for loop starts I at 0, and runs while I is less than 3. Each pass we use I as the index to access fruits of I. So on pass 1 we print apple, pass 2 we print banana, and pass 3 we print cherry. Then I reaches 3, the condition fails and the loop ends. This pattern, looping from 0 up to the length of an array, is one of the most common things you will write in any language. The loop adapts to the data, rather than making you write a line for every item. Let's wrap up what we have learned. Alright, let's bring it all together. A for loop has 3 parts in its header. The initializer sets your counter once before the loop starts. The condition is checked before every pass and stops the loop when it goes false. And the update advances the counter after every pass. Together, they give you precise, readable control over repetition. No copy-pasting, no chaos. You saw how that works counting from 1 to 5, and how it scales naturally to walking through an array. The key takeaway is simple. When you know how many times you need to repeat something, a for loop is your tool. From here, great next topics are while loops, which repeat based on a condition rather than a fixed count, and nested loops, which let you work with grids and tables. Give this a try in your own code, and thanks for watching. Keep on building.